Hello everyone, this is Koushik and I'm with my teammate Poornima. I'm making this video regarding foundation design assignment from Skyfi Labs. So here I have opened eTabs. This is my building module. You can see the building model where the first story plan is on this screen. Now you can change the plan to story 6 where 1 to 5 is of that plan I showed you in the previous one, and now 6th to 9th story is of this plan, and you can go further from 10th to 14th story, and finally from 15th to 18th story. This is the plan of my building model. Now I have applied live load, dead load to this building model, and I want to get the uh, column loads at first floor of my building. As to design the foundation, I need to know what are the forces uh, it is giving to the soil, so I can design a proper foundation. Now to do that, what you have to do is go to the model explorer, there select tables. From there you select analysis result, then elemental output and frame output. From there we need column results, so select this column results, right click, and now press show table. Now you can see the table, which we can see the loads and moments which is acting on the respected column. Now as we need story 1, now you can filter it by clicking right click on story 1. As you can see, story 1. Now first we need to get the values of dead loads and live loads that is acting on the base of the column of story 1. So output cases, let me select it to dead load. You can see that the station uh, select sort ascending. Here you can get the loads. These are the loads. Record these values. You have 16 columns. There are I have given two inputs for the column. One column is of 550 mm cross 550 and 600 mm cross 600 mm. Now after you get recorded the dead loads, now go to output case and select live loads, and you can see the values for the live loads. Yes, here we are done. Now once we get the live loads and dead loads, now then close the window and let me open Save 2016 evaluation version. Okay. Okay, just a second. Yeah. When we open this, now before opening it, you have to calculate what are the dead loads and live loads coming to it. Now basically if you take in eTabs, let me go to the plan 1, story 1, sorry. Here you can see the columns right here, right? But there are changes in column C7 and C4, that is 600 cross 600 column. So as you can see, which is 600 cross 600 column, which is C1, C2, you have to know. To know that, we need detailing option, but which is not available right now because it is not used for commercial purposes. So you have to buy a licensed software for that. So instead of getting complicated, just select any column and right click on that. You can select the column and you can get the column name. Easy, right? When you get the column name, you can note it down, the column names. After noting it down, then you have to know, I told you there are two types of column, right? But to get the dimensions of the column, it's very simple. Now go to select properties and frame sections. Most of the column sections is 550 cross 550. Let me go to 600 cross 600, select and close. Now when you observe closely, select the rotate option. Now just rotate it. Not yet. Nothing is visible right now. Let me rotate it a slight more. You can see the two columns are highlighted. So which is 600 cross 600 column. So this is how we can tell the difference between the columns. But it would be easy if we had a detailing option, but it is not available right now. So I have I have taken only two column values. Okay, once you get it, so I have named the columns. So the length and breadth of the foundation is actually 21 cross 21 meters. Mm, so I am first I have to calculate the um, yes, column strip width and subgrade modulus. To get the subgrade modulus, what you have to do is uh, taking SBC of the soil as 300 and allowable settlement as 1 centimeter. Now subgrade modulus is equal to SBC divided by allowable settlement, that is 300 by 1 centimeter. So you get 3 into 10 to the power 4 kilonewton per meter square. This is the subgrade modulus. From there, if I calculate the column strip width, so that is 0.25 times L1 and L2. So as you can see, both L1 and L2 is of 21 meters. So when I multiply 0.25, I get 5.25 meter. That is the column strip width. So as there is no concrete provision for strip width, I can choose as 5 meter. When that is done, now we have to start designing the foundation. Now select the file tab and click the new model. When you select the new model, first you have to check the units that is currently metric. It should be okay. Then design preferences. First you have to change the design code to IS 456 Indian standards. Then go to design preferences. Minimum cover thickness of slabs and beams are given here. Now we'll come to minimum cover thickness of slabs according to Indian standards, that is 50 mm. I'm changing it, and let me prefer the bar size to be 22 mm. Now click on OK. Once it is done, as it is a matte foundation, now I'm going to select grid only option. So when you select grid only option, it's gonna ask the number of grid lines in X direction and Y direction. As I said, our foundation mat is of 21 cross 21 meters. Now I'm gonna take axis of 2 meter offset on both sides. So if I take axis of 2 meters on both sides, then it will be 25 meters. So the foundation length and breadth will be 25 cross 25 meter. So number of grid lines, so It is 20. First, don't try to uh, make the foundation with 2 meter offset. Now I'm doing it for 21 cross 21 meter. So number of grid lines will be 22 in x direction, and in y direction also it is 22. And grid spacing, it is of 1 meter each. Now click on OK. You can see the grid lines has been appeared. Now let us define the materials. First, define materials, add new material. So I'm gonna we have designed the building of concrete M40 grade and the steel bars of HYSD 500. So first let me change the properties of M40 concrete. Let me material type is concrete. As you can see, this you can change it to 25, and these are the predefined values which you can get in the internet easily. M40 grade, I have defined M40 grade. Now click on OK. M40 grade is done. Now we have to define HYSD 500. So rename it as HYSD 500 grade bars. Now change this to rebar unit per. It's also a predefined one. FE 500, right? So change it to FE 500. Click on OK and OK again. I have already defined the materials. Now let me draw the slab. Okay, you can use quick draw slabs or areas. I'll just select it from one end of grid point. Now, before you draw, first you have to define you can draw quick draw slab areas. Yeah, it is asking slab 1. So let me define slab properties. You can modify the property, that is M40 grade, right? Let me assume the thickness of slab to be 500 mm. Click on OK, then OK again. Now you can draw quick draw slabs. It's the thing. Select the first point. It's getting, yeah, select the first point, then the second, yes. You can do it in this way, or you can use individual one by selecting 3 points. In this way you can draw a rectangle. If it is trapezoidal, use this tab. If it is rectangular, you can draw quick draw slabs or areas. Okay, when it is done, now what I have to do is offset it. So select the footing. Just a second. Draw. Yeah, not that option. This is the option. Sorry. And select the points. Yeah. Now close the tab. Now select the foundation and then I have to give 2 meters of offset. So edit areas, expand or shrink areas, their offset value of 2 meter, that is 2000 mm. Okay, you can see the extended way. Now I have to define columns. So to define columns, go to column properties, define column properties. So we have, I told you, I have designed two types of column, two dimensions. So add your property column 1. If you want to name it as column 550 cross column 550. Change the material to M40 grade. Then it is 550. 550. Change the dimensions. Then click on OK. And add another column, that is column of 600 cross 600. You can change it here on OK. You can check the properties by going and selecting them, modify or show the property, and click on OK. Now I have to define the soil property. So to define the soil property, click soil subgrade properties, modify soil 1. So change it to 3 plus 4 because our SBC of soil is 300 kilonewton per meter square. Okay. OK again. Now let me draw the columns. So to draw, quick draw columns. Be careful while drawing the columns. Property above is C550 cross 550. Property below is none. And height below is 0. Height above is 2 meters. Now you have to select the columns. So just click it and this points will guide you. It will show the meters. This is 7 meters and 7 meters. There you go. Then 7, 7, just move aside, 7 meters, yep, seven meters, 7, again, yes. Now change the property to 600 cross 600. Yes. Now close it. Press escape. Now we have added the columns. Now select the foundation, assign slab data, properties. I'm assigning the property and assign, before you assign, select it. Support data, soil property. I've assigned slab in soil property. Now I have to assign the property of individual columns. So zoom in, select the column, it is C1, assign load data, point loads. Before that I have to assign column property, right? So to do that, I already defined column properties. Now what you're gonna do is